Hi, welcome to this Open Security Summit session in April 2023. And here we have Marcos that we're going to talk about Zero Trust Database Access using OpenZiti and JDBC. Over to you, Marco.
Thank you very much, and welcome everybody to this small presentation. Basically, the idea here is show you how you can start have more control about connectivity, how more control about security, and basically start accessing the different assets in a secure, in a securely fashioned way, right? So, in order to get started, I'm going to introduce myself. My name is Marco Schejtman. I've been over 15 years experience in basically cybersecurity, most likely, and a little bit on infrastructure. I'm super paranoid, and I'm actually a video game amateur player, right? I love playing StarCraft, Overwatch, although I'm terrible playing, I do like it, right? And most likely right now, I'm focusing on evangelist and basically everything related to SOC building, zero trust, OT security, IoT security, etc., 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 right? So let's get started to this topic, right? Which is, at least for me, something really, really interesting in order to make it happen. And in order to get any idea of what we are going to discuss, let's see the regular basic deployment production we as a developer used to do for different companies, right? We do have or basically what it's called or application. On top of the application, right? Whatever we're building on the application, we always put our firewall, and of course we can put also the web application firewall. We can put the load balancing on top of it, right? And any other different things that we are basically those different layers that we are using in order to make it secure, right? But what is the big problem about this scope that we are basically regularly taking every single day? Well, we have our attackers, right? The attacker may try to reach out to different services, just basically using the gateway. The web application firewall most likely will work using signatures. And these guys are especially known because they only find a way to basically avoid the signature that there could be currently on top. And of course, we can basically exploit any zero-day vulnerability that they can have or they have discovered at that time, making it so difficult for us to basically being able to protect, effectively speaking, our solutions or application that we are actually exposing to everybody, right? So the future is a little bit scary, right? Day after day, we find out that different breaches, different basically vulnerabilities, different exploitation they're currently doing. And yeah, that happened recently, right? People can actually get scared, and people is actually getting still every single day that it's coming, right? And on the security perspective, that's not the only thing to keep in mind, right? We as a developer, so when we need to collaborate with somebody else, what is the other thing we're using? A VPN, right? And VPN, it's having with it lots and lots of other issues, right? How to solve it, IP overlapping, all the kind of stuff that just making it so complex to do, right? And finally, as developers, right? You probably have heard, not only as a developer, but basically as every person, probably have heard the latest about the chain, right? How they can, or how hackers, attackers, and actually get into one company in order to basically being able to populate or to send their attacks to any others, right? And the other the way they do it right now, or the new target they're basically reaching out are basically the DevOps team, right? Everything related to the CI/CD tools, monitoring, data warehouse, configuration manager, basically everything that the DevOps is using. It's a gold mining for the attacker, because the attacker can just start embedding their own bad code on top of it to basically being able to spread the ransomware, right? So it's hard. And what can we do about it? Well, in first place, we need to recognize what is the current model of the networking that we are currently using, right? That is important in order to understand how can we avoid all this kind of stuff that probably might be happening right now. And in the regular network, what we're going to have is our attacker, right? And the attacker basically is going to have, or it's going to try to move laterally to any different servers, right? And probably the attacker is not going to be able to reach out our castle or assets, right, in a direct way. So what is going to try to do, or what the attacker is going to try to do? Well, basically, is going to try to send communication to any other endpoint that may have that access, that may have the basically the keys of the kingdom, right? And that's the easy way they can do it, because basically they move from there and they can start right now from this machine. They can just now move laterally and basically reach out any other service as they basically need, right? So the first thing we need to do is first recognize that the perimeter has evolved, right? I recall when I started working in this basically space, right? We used to say this is the physical perimeter, right? And we used to protect our data centers. And that's probably one of the reasons that when you go to the data center, you need to present any number of credentials. And basically you need any number of bureaucratic processes. And don't get me wrong, those are perfectly fine. The only issue is that we recognize how to protect them in a physical way, right? And then we move into the network, and then we start saying, okay, in order to protect the network, we need to put the firewall in there, and then probably a web application firewall as well, and the DMZ, et cetera, et cetera. So basically, we are promoting this physical mode into our networking, creating these virtual barriers between each one of the different stages or of network, right? However, right now, we know that not necessarily the network is what we are working on, right? We also know that there is something else, and this is the application, right? The pandemics actually taught us, right? Those companies that probably we were not ready at the beginning, the pandemics just show how we can actually start working anywhere just using applications, right? Assess applications, just mobile applications, whatever. But basically right now, we cannot protect just basically physically, right? We cannot protect just using just a firewall, because I'm working from home. I don't have a firewall to can protect me. I can probably start working from the beach, or I can start working from a coffee shop, et cetera, et cetera. So there is not actually an easy way to identify right now what is the perimeter that is surrounding us, right? So we need to recognize the new perimeter is the edge. It's the application right now, right? And this came with lots of benefits, right? When we start talking about distinguish or basically acknowledge that the application is a real perimeter, well, we're going to be able to create something that is called microperimeters. And that is going to help us because we're going to start reducing the surface of attack, right? That the attackers may have, right? We are going to dissolve legacy technology, VPNs, right? This is for starting. I just a couple days ago, right? The US government just released a new document about how to make it happen, right? Security by default is the new model, right? So trying to dissolve all these legacy technologies and be more aware of the basically the new time we are approaching to and we are living to, right? It's also going to help us to basically do a breach mitigation, right? It is not the same saying, oh gosh, this ransomware has spread across all our computers and servers. They just say, yeah, well, unfortunately, we're going to hit on just one server, right? Because basically it cannot move laterally, right? Because we have done this micro segmentation, we have done this micro perimeter across the different applications, et cetera, et cetera, et cetera. So basically this kind of stuff is not going to be catastrophic when we start doing that, right? So that is an immediate benefit of just recognize that the application is the new edge, and basically we need to start protecting around these applications, right? So in order to do that, and before getting into what is the CDBC and how we can do it, it is important to understand what is OpenZiti. OpenZiti, it's just basically an overlay network. It's an overlay network that is going to work on top of the internet. What internet? Your internet, my internet, anybody's internet, right? The 5G, whatever, right? They're not using, or it's not going to use any specifics. It's just only going to use the regular internet, no matter where we're located onto, right? And in order to protect this, we are going to start working with different solutions or with different sites or different parts of it, right? The first one is the controller. The controller, as you can imagine, right, the control plane is the one that is going to authenticate us, is going to tell us if we are authorized to consume any different service that might be located on top of our overlay network, right? On top of that, we're going to have the routers, and we can say that we have to do different type of routers. The first router we're going to discover is this one, which is the edge router. And those, right, those routers are the only ones that are going to have a public IP available. And the reason behind that is that somebody or any other customers may be able to connect to those if the controller says that I can actually do it, right? And then, of course, we're going to have some other routers, and those routers might be on the fabric, on the overlay network that we can start creating, or at the same time, they can be on somebody else, right? Where they can be, well, they can be in our own infrastructure, it can be on the data center, et cetera, et cetera. The reason behind those routers is that they can work as a mesh healing factory, right? As much when we start putting more and more routers, we are going to find, or the solution is going to find the closest path basically to that, right? And then, of course, after we have our routers, we are going to have full mutual communication between each one of those, right? And finally, of course, we have the applications. The applications are going to have completely outbound communication to the public routers or the edge routers that we are actually putting on top of it, right? So that's the way we're going to have a full communication. And something to keep in mind is that this information might be coming from the endpoint or might be coming from a full application that has communication to each other, right? The beauty of this is because everything is outbound, there is no single port I need to open on this side, and there is no a single port I need to open on this side, right? Everything could be and can be on closest ports, right? No listening ports, nobody. And the only one who is going to decide who can actually have access to consume this service or this service that's living here is the controller, right? The controller is going to tell me, oh yeah, you can move on. Or, oh no, you don't even know what is this, right? So there is no possibility I can basically do expectation because there is nothing that could be exposed for me in the first place, right? Just for the starting. And with that, we need to understand that this solution, right? OpenZiti is going to provide us different way to access our applications. The first way is going to provide us is something that is called CDNA. And basically, that's the regular use case that probably most of us are used to, right? And there is basically some kind of VPN site-to-site communication. And basically, on the Zero Trust Network access, what is going to happen is that we're going to have a router, right, located in probably our data center, and then we're going to have another router located probably in a cloud provider. And what is going to happen is that I'm going to say, you know, everything that is coming from this router can be able to reach out everything that is located into this other router, providing that probably all my users, right, in this data center can actually have communication to all the services, all the hosts located on the OCI or the cloud provider or whatever is my cloud provider location, right? So it is completely possible to do it. But of course, we can also extend this a little bit more. What happened when I don't want to allow that every single customer or every single my user may have access to the other side? Probably I just want to have one-to-one communication, right? From my own computer to basically the production server, to the database, etc. So how can I do it? How is that possible to do it? Well, we can have something called Zero Trust host access. And we're doing host access is that meaning that basically we're going to install a tunnel or a client on each other side. And basically we're going to provide full communication between these two sites, which means is that nobody internally is going to be able to see the traffic because everything is going to be completely encrypted. And of course, we are going to reach out the other party in a secure fashion way, right? But finally, you may say, you know what, Marcus, if a hacker has control of my computer, it's going to be able to try to reach out anything else, just trying to install any rat application or kind of like that. Well, you can have something else, and you can have an application embedded or something that is called zero trust application access. And what it means is that you can actually embed the SDK in the application on the client side or the server side, and basically provide full communication. No need at all to basically expose anything. No need at all that if a ransomware connecting to my computer, it's not going to be able to reach out anything else, because the only one that has authorization to communicate to probably the database is going to be my client. And that's it, right? That's the only way I can basically start doing that. And that it's an easy way to basically provide security to our applications. So if we already know what is the overlay, and we already know that can help us, what are the superpowers, or what are those powers that we can actually get when we start implementing basically OpenZiti? Well, we're going to start seeing it now. The first one is addressability. Basically, you're going to be in control of your own DNS and your own networking, right? And this is huge. If you're providing like MSSP solutions or kind of like that, you know that IP overlapping is constantly happening all the time, right? And it is normal, right? I recall, and basically even when we do have a lot of segments or the private segments in the IPv4 space, we used to choose always the timer, right? The 192.168.1 or the 192.168.100 or the 172.16.16, etc., right? It is always, on regular speaking, it's just the same networks, right? So IP overlapping is constantly, right? Well, OpenZiti is going to allow us to basically move from that to create our own space. We can use any kind of IP addresses, or we can just use a private DNS and start talking about, we are going to talk about the naming of the endpoints connecting to the services I do need to, right? In this particular case, I'm going to allow the client workstation to communicate to the Jenkins service, not the Jenkins host, right? He's not going to have access to probably the SSH, just the Jenkins service, right? And that's it. Of course, this implies that I can also change the port, right? And I can just decide that probably every single service is going to listen on the same port, the 443 or the port 80 or whatever port I'm actually required to. So that means that I can also start working with security by obfuscation, right, in this particular case, and start connecting to each one of those, right? It is not going to be super standard, super compliance, but it's going to help us to start protecting our solution. And keep in mind, again, this is an overlay network, so I can modify every time I need to, right? App embedded on the server side. And yes, as you can imagine, that means that we can put something in front of our application, the SDK on top of the application, and basically no need to opening the port. Is that a Kubernetes application running in? Well, don't worry, you don't need to expose it, right? You don't need to expose, basically, you don't need to tell the cluster that you're actually listening on something. Just basically, you can use our solution to reach out the service completely in an automatic fashion way, right? And this also works because it's going to be able to protect for basically anything. I don't know if you recall 2 years ago, the Log4j stuff, right? It was a big chaos. We need to patch at that time probably like 3 times, because the first one was the current Log4j, but then it had another vulnerability with an DOS, and then another and another, etc. It was a mess, right? Well, you know what happened when the attacker can exploit that, especially on a 0-day? We don't have time, right? Our mean time to detect basically reduce a lot, and we need to act faster. But if we are putting our solution on top of it, it doesn't matter that we actually have the vulnerability. Of course, we need to fix it as soon as possible, but we're going to have more time to basically do those changes, to test if it's not going to affect, because basically only authorized services, only authorized identities are going to be able to reach out or solution or application. And the attacker, who maybe is going to try it once and see if that happens, well, he's not going to be enrolled, or he's not going to be entitled to basically being able to reach out the service and access it, right? And of course, this means that we can also certify the client as well, right? Being able to access different ways to the different services, no matter where I'm located at, on the browser, on an SQL client, etc., 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 right? And to be honest, using the SDK, it's super easy, like 2-3 lines easy, right? And this can see, and as you can see on the screen right now, it's just a Java example, right? Super simple, but you can see this is the regular stuff we used to do, right? We basically say, you know, I need to open a socket channel, and basically I'm going to put the listening, right, in this particular port, right, in this particular host that I'm getting it, right? And then I'm gonna get and accept everything that I'm processing as I need to, right? The city way, super easy, right? We're going to initiate the communication, right? That's basically us communicating with the controller and say, hey, can I raise a server? Can I put this or that, etc.? That's something, that's the only thing that we're going to do. And then after that, we're gonna say, you know what? I'm going to bind, but not on this particular IP or this particular port. No, I'm going to bind with this service. And that service is gonna have its own information. That service probably is going to put me into the port 80 or the port 20 or the port whatever, right? It's going to give me some way to accessing it, but I don't know that at code time. And that's the beauty, because I don't need to mess with it, right? It's gonna be super secure and everything is gonna work as expected, just as easy as that, right? And basically, I don't need to know the IP, I don't need to know the port, I don't need to know anything on this particular way. And that means that is going to help us, because if you recall the original model of the network, what happened in that? The attacker may move laterally in order to access it, because basically he's going to, for the endpoint, he is going directly to try to put something in the endpoint so he can have access into. But if I embedded the application, that means that he should know how to access in the application. He should know how to basically start, but he cannot exploit beyond that application, because I have put everything in my own solution. And basically the attacker, right, needs to know that the SCCP, it's only going to be able to send SCCP information. The SQL is only going to be able to send SQL information. If the attacker is trying to do basically an SQL, an FTP, or whatever in a different port as we configure, it's going to be completely impossible. That also means the solution that's Nmap, etc., are not going to work, because basically this is only entitled for the solution, for the application that we are just building at this particular moment, right? So this is the beauty. And of course, we are talking about CDBC, and this is more likely for Java development, but guess what? You can basically use it anywhere. We have SDK, and there is an SDK for basically anything that could be used. And this is the beauty of the open source as well, right? Being able to basically reuse the code and put it anywhere. Develop once, develop any, or deploy anywhere, right? And I don't need to nail, I don't need to mess with the networking anymore. It's just as easy as that, right? So CDBC, let's get into the mood. Let's try to understand a little bit more on how this CDBC, or what is and how it works, right? At CDBC, basically, or why basically certifying CDBC? Well, first, you already know that JDBC, it's the standard de facto to access any database, right? Could be a relational databases, but basically kind of any databases that could be self, right? At the same time, right, not that long ago, a company found out that many databases contain vulnerabilities, and this could be related to many things, right? First, obviously, upgrades, updates, etc. And secondly, it's, as we saw, right, basically the code, we need to be the DBA, the developer, everyone, it's trying to run with the business, right? It's trying to move, the business saying, we need to do this, we need to deliver this, we need to deliver that, and these are the dates. And when the new vulnerability happens, well, it's just put into the queue, right? So it is hard, to be honest, it is hard to stay on top of the vulnerabilities, and then of course, to stay on top of releasing the new version with the new features, etc., right? So if you sum up that plus 6% of the vulnerabilities on the databases are normally high or critical, Well, it's trying to make more sense, trying to defend or put the database protected, right? Trying to put it somewhere where the attacker cannot reach it out. Plus, let's keep in mind that most of the cases, the database is going to contain information from us, right? Information from our customers. So it is critical to have that information secure, right? To have that asset completely protected. So how we can do it? Well, basically, there is a way to certify anything, and that way is just starting certifying the JDBC. And certify the JDBC is just basically say, you know what? We're going to make that any JDBC communication, it can work using basically the overlay, right? And it was quite easily, right? It is super easy. As you can see here, one of the ways you can start doing it, right, before, right, doing the CDBC, for example, and it is just basically initialization of the SDK that it's connecting with OpenZiti, and in sometimes just modifying the socket subfactory that probably that particular JDBC is using like this one, right? But you're gonna say, you know, Marcos, that it's only happening into the code, right? How can I make it in, for example, an SQL client? Well, using the CDBC, it's completely possible to do it. And the only thing we need to do is just tell, right, our solution, whatever it is, that we are going to use another driver. And that's the driver we're going to put. Our driver, it's only going to have one small modification. The first one, right, as you can see, instead of starting or current URL with the JDBC that we currently know, and then the completely URL, etc., we're to modify the JDBC, but just at C, right? And CDBC, that's gonna be the new path, the new URL that we're going to use. And of course, we're going to use some other properties in order to make it happen. We're going to use the city identity file in order to make, hey, you know what? You're going to use this key. And guess what? If you don't want to send the key in plain text, that I think nobody will want to, right? You can also put it into a wallet and just make it happen and just send the wallet and protect the wallet as you currently do right now, right? And protect it using the application server that you probably are using, or protect it in any different way, right? So it's super easy to basically just make it happen and just get started with it, right? What are the goals of this CDBC, right? Because you may be thinking, oh man, so you are going to, or you will need to modify basically the application for one application for the Postgres, for MySQL, for Maria, for whatever. Well, not necessarily, right? The first goal is not modifying existing code driving, right? And the reason behind that is because they have already invested so much time and so much resources to make it happen, right? To make that basically driver working in a way that is going to provide probably more reliability and more performance. So we don't want to modify those existing things, right? We just want to make it happen, to make it, to use it as a backbone, basically. We want to make it as simple, right? For any customer application and for basically any third-party tools that could be embedded, right? I'm probably using DB Beaver to connect to my databases. I want to use it here, right? To make it simple to use anywhere, wherever it is, right? So how does it work then? Well, what we did, or what we are doing with CDBC, is just basically a wrapper, right? What is going to happen on top of it is that we're going to deliver some shim configuration, and basically what is going to provide that is that it's going to send us directly to the vendor driver, but using our solution as the transport to send that. So basically, long story short, is that we're going to open a city socket, right, to the other party, and the database is just basically just that city socket to communicate to the database in a secure way, in a basically easy way. We don't need to modify anything. We don't need to modify codes. We don't need to do anything else, just adding our solution as it is. And as we saw, the only thing we need to modify is just the starting of the line, just to put the C. It's saying it's using our stream, or it's using our configuration in order to communicate to any database, right? Plain and simple, that's it. It's the only thing it needs to be done. And what is going to happen if we don't have the shame for it? Well, don't worry. We have added into the solution, again, right? A couple other options where you can basically do the regexing of the stream, right? In a possible way, or in a way that basically is going to be completely possible to modify the platform and start using it for any other driver that could be, that not necessarily can be available at this moment right now, right? And yes, it can be used anywhere else. You can use it on your clients, but you can probably using any kind of web application server, and you probably rely on the application server pool technology to create those things. So not necessarily you want to put it, or you want to make it only accessible for the code, right? It is not just going to be an application. Probably is your application that it could be located on the cloud, communicating with your databases, or it could be on-prem, or vice versa. The database could be on any cloud provider, and you need to have communication there. Well, don't worry. This can be done easily as well, right? You can just basically onboard the same JDBC in your application or web application server configuration and do the same, right? Just adding the new identities or adding the new properties to that one to provide that communication easily, right? At that moment, no issues at all, right? So let's see a little demo so you can see, you can feel the platform, right? How it works, what it's doing, etc., etc. So I'm going to stop the sharing right now. Well, I'm going to modify a little bit that way, what I'm sharing. And I'm just going to show you a little bit of what I'm doing here, right? What I do have, it's, this is the solution. This is just basically the code, how I build it, right? So you may have an idea of what we're going to present, but basically it's first simple, right? I do have this virtual, or this workstation that it's called Apollo. And this workstation have access to different things. For the database or for the communication, we have created also one database server that is located in Europe, right, in a London data center. And we also have a US one, right? This is located at the New York data center, right? So I do basically have different solutions. Right now, I'm located at Charlotte, right, in North Carolina. So basically, I don't have access to any of those. At the same time, we do have an application. This application is basically using a Python code, right? And you will see different things, how this basically it is working and what we can actually achieve on this, right? So let's get started and let's see how it's working, right? The first one, as you will see, is I'm going to do basically just a single SSH. This SSH is going to be sent, or it's going to be basically to the application, right? Oh, I think it is, okay, it was frozen for a bit. So I'm going to do an SSH to that particular server, right? You can see here, I'm connecting basically to the US database, right? I'm just going to do, I'm going to use SSH. And the idea behind that is that I should be able to basically reach out this server, right? In an easy fashion way and connect to that, right? And then you can see here, I do have the access. This has obviously an external IP address as well, where I can communicate with it. But basically, I'm just in that server, right? Nothing fancy at this moment, just easy as that. So you to know that we're not doing like anything crazy, I'm going to connect also to the European SQL server, right? And basically the idea is that you can see that I have access to both of them. They are located in two different locations, right? They do have two different IP addresses. So basically I can just do the curl and you can see again, right? This is a completely different address where we are located into, right? And how I access these servers? Well, basically I did access those servers because my application, right, is having access to those. If you take a look into this, you can see that actually I'm providing the access to this particular server via IP address. I define this particular IP address for it, even when, as you can see, this one doesn't have any 172 IP, right? This is the 1066, and probably this is one other IP. There we go. Yes, different IPs located completely different. So basically, as you can see, I'm just locating, and I can have access to it in any fashion way I do want to, right? Not just that, you are going to be able to see also that I do have access to different services, right? In some other way. But there is only one port I can access to this, and this is the port 22. And actually, it makes sense if I disconnect from the SSH and I just say, you know what, I want to do a telnet to the Postgres database, right? And Postgres is listening in the 5432, right? So I can use that and just say, you know what, send me a telnet on this on the 5432. What's going to happen is that, as you can see, my machine doesn't have access to that one, right? It is impossible to basically communicate to that because the agent policy or the policy that was deployed on top of here, it's just basically to provide communication to SSH, right? So we are doing segregation. It is not possible to do it. And actually, you can see that the resolution is not even close to the IPs that this server may contain, right? So now you may be wondering, okay, Marcos, so you just proved that you have SSH access. How can I connect? Well, the easiest way to connect is using our client. This client, this is a SQL, right? Nothing crazy. And you can see that basically I do have here configured the Postgres data driver. And in the Postgres driver, you're seeing that basically for the driver class path, I'm just using the Postgres, right? Nothing else. It's just the Postgres driver. But I'm also using the CDBC, right? The CDBC is located on the OpenZiti project on GitHub at open source, Apache 2 license. So basically, you can use it anywhere you want. And what I'm telling is, you know what? The class name to provide this driver into Postgres is going to be the City driver that we just created. And the URL is going to be modified by CDBC or JDBC City Postgres, right? So that's it. And I do have a couple of aliases. You can see here, right? I can modify this alias so you can have an idea what I'm doing. And basically, you can see in here that I'm connecting using City to this same IP or same name with the port that I basically test that I don't have the access to communicate to, right? So I can just say, you know what, connect me to the US database. And what is going to happen is that the application is going to have the solution, is going to have the proper requirement authorization to communicate to this particular server. And in here, well, you can see, right? Basically, I can just show information. I can just show any tables, right? I can just basically do whatever I want, and I can see the content on it, right? I'm working on the SQL database, and my server, my workstation, don't have access to it. Whatever else I try to use is not going to work. And this works using a domain as we did in here, but it's also working if I use an IP. Which IP? The IP that I basically and explicitly select that I can use to connect. So you can see this is the same database, but in this particular case, I want to reach it out just using the IP address. Once again, I'm going to use this external IP address, and I have exactly the same information. I'm connected to the same server, running on the same Debian device, and running everywhere, right? So basically, I do have the possibility to just communicate anywhere else, right? In just using the CDBC driver that we are setting up here, right? So, as you can see, this is huge because it will allow you not only to provide a secure access to your developers, to your DBA, but also eventually to provide a more secure access to the application by itself, right? Any remote code exception or any remote code injection that they may have, and they probably will gain access to the application server, well, it doesn't matter, right? The server is not going to be able to move laterally. The application will, but not the server by itself. So we are reducing the basically scope of the surface of attacks, the surface of the threat. It's getting reduced and reduced even more and more and more, right? And just a couple of other examples to show you, right? I'm going to show you another one that I completely like. And this is because the power of basically this SDK that you can integrate. We focus on the CDBC, of course, but CDBC, it is just one of the different applications that you can do with OpenZiti, right? The other ones are, for example, putting a server running behind the scenes, right? So in this particular server, right, you will see this is the server again, right? You can see all these IP addresses. You can see what is the external IP address that got assigned to it. But in this particular server, I do have a Docker or a container, right? that is running. And you can see that this container is not having any port available. And actually, right, if I try to reach out this particular server, I'm going to try to reach it out in here. You can see that actually I'm not able to, right? This is the way I want to access it. And basically, I don't have access to it. However, we're going to connect to the server, right, to the Docker. Obviously, I know I'm not following Docker interfaces or Docker best practices to provide it, right? But the idea is that you can see when I try to run, right, my application, and I'm just gonna say, you know what, raise this server. This is going to be a Flask regular application, right? And you need to use this internal service. This service is just basically a service I just created into OpenZiti, right? If this is a service that is going to provide us communication, it's a web application communication, but it's only listening into the overlay network. And what is going to happen is that after I just did that, I basically have access to the solution in this fashion way. And of course, this will work if I want to send information just using Postman, or any information I will want to send is going to be able to do it. And the reason behind that is because we do have the ability to basically embed on top of the different application as I want to. And finally, right, even one more solution you can provide just using OpenZiti. I know, right? I love it. It is a great open source solution, basically. And the other thing you can do is basically start sharing, right? How many times you need to share your basically space, right, on a document or basically any kind of service to somebody else, and you are using basically any probably free solution on the top to share the file or to share the service, right? How many times? So probably a little bit, right, of those. Well, OpenZiti, right, thanks to the SDK and thanks to many other things, you can also create this type of sharing tools. And in this particular case, I'm going to share with you one simple sharing tool that is being built on top of OpenZiti as well. And this sharing tool is called the Xerox. And basically what I'm going to do is I have put a server, right? And you can see if I go to Xerox test, right? Xerox test, there we go. There is here a couple of files that I want to share with you all, right? So those files, it's an easy way to share it. So how can I share it with everybody? Well, I can just basically say, Xerox, you know what, OpenZiti, I want to share in a public way this directory, right? And I want to do it using a web application. So this is basically what we're going to show you. And what is going to happen is that I do have this query, right? Or I do have this URL that I can basically access, right, at any moment. And basically what is going to happen is that you are right now, if you're typing it now, you're going to be able to reach out my computer and have access to these two files, right? And we can show you that basically if I can just say that it's working, it's going to send me the file that I just select. So basically this is just working, right? And it is just showing you just a single file. And of course, at the moment I decide that you are no longer have access to it, I can just click it, close it, and there you go. It's gonna have full, or I'm gonna lose communication to it because it's not longer gonna be working, right? I can just take it anywhere else, right? Any other, basically a browser that doesn't have like the cache enabled, right? Or we can also open a private session. And what is going to happen is just that, right? It's just going to remove all communication that you used to have on it, right? Because there is no more access to it. I just close it out, right? So providing that basically you have full communication and you have full access to anything you want to share, right? So in conclusion, right? To get to have some time for probably some other questions, let's keep in mind what we can basically do it, right? And how to get OpenZiti, or what we need to, oh, I think I there we go. Yeah, I messed it up. I just double click. All right, we're going to share it again. So yeah, in conclusion, right? What I highly recommend is just getting OpenZiti. It's open source. It's going to help you, and there's many ways to basically get it, right? You can go to GitHub, just download it. You can go to citi.dev and start working with it, we have multiple options. We do have the quick start. You can just put any OpenZiti in there, right? And you can just launch it, create your own network, start sharing whatever you want to, whatever you need to, as you did, right? Start moving with the servers, start moving to databases, start moving for basically anything you want to, right? So yeah, I don't know if there is any questions for the public right now.
Yeah, look, this is pretty awesome, right? Like I have to say, I wasn't fully aware of this tool. Now I have tons of questions. So can we start with the last example, right? So you're saying you're sharing some files, right? From so like one service I've used in the past is a service called ngrok, if you know that. Right.
Yes.
So is this kind of equivalent? So what's the requirement? So you need to have an agent on your computer, which is the sort of almost like the routing, the local traffic router, right?
Well, not really, and that is the beauty, right? This solution can work with agents or without agents. So for example, I'm going to shoot down all my agents here, right?
Yeah.
What is going to happen as long as I do that, right, is that, let me close this a little bit. My machine just got a little bit slow. So what is going to happen, you can see right now, right? It just got me disconnected from the server, right? I no longer have access to any SSH, basically. And the reason I no longer have access to it is because I shut down the client, right? So you can see it disconnect me, right? Completely disconnected. So I don't have the access. But still, if I run it, this is quite similar to ngrok, as you said, right? The difference is ngrok is just a public available service that you use, not open source. But in here, you can mount your own instance of similar zrock, right? And I can just click it. I can just share it again, right? As you saw, I shut down my agent. The agent is not working. And it's still, if you access this, right? I'm going to put it in the chat. Bear with me because it's a little bit slow.
So from a technical point of view, what this is doing is your container is sending the traffic to, well, that tool you built, right? This particular one is sending the traffic to the exposed service, right? That's like you said, we can run our own or we can run a managed service on top of it, right?
That is correct. Yes. So basically you have that ability. My computer is going to send the traffic or everything is going to be using that. And I don't need to open any port, right? I don't need to expose it and nothing. I can just share that URL or any URL that the system is going to provide me at that moment. And I can just share it with you. I can just share it with anyone and they can start accessing to it. I just finished the share. I just close the share and nobody else is going to be able to access it, right?
Yeah.
And particularly, I mean, for the zrock, I think somebody else in some other session, they're going to talk about it, but we can discuss mods in different ways. But basically, for the zrock perspective, you can also share it in a private way and just say, you know what, this is going to be shared, but only those that are actually part of my overlay network, not necessarily publicly explicit, but it's only private to my basically network.
Yeah, and that's the kind of policies I think I saw you mention, right? That you can apply almost point-to-point policies based on application, right? Based on identity and that kind of stuff.
That is correct, because as this is an overlay, everything is going to become an endpoint, right? Remember, we're trying to move this concept that the endpoint is just a computer right now, or endpoint or edge is just an application. So right now we're saying this application can connect to the SQL. Any other application running on my machine can't, right? Yeah. So for example, you saw that I shut down the tunnel, right? My tunnel is no longer working. And it's still, I don't have access to the databases, right? If I want to have access to the database located somewhere into the US, for example, this database, I'll be able to connect. And the reason behind that I'm able to connect is because my machine can't, but this SQL database, right, client, this one can, right?
So I guess, is it correct to say that one of the advantages of the agent is that it will probably require, in some cases, less changes, right?
That is correct. So you have the ability to basically communicate to anything you want to, right? You have the ability to put the agent, and the agent is going to provide the full access to your computer, or you can just certify that it's the word that we are using. And basically, when you certify that, you are able to just provide the access to that specific application you may want to.
Yeah, cool. So in terms of the server side, what you're creating is almost a mesh network, right? With the agents that get installed, or the server instances, right? And then is that correct to say? So for example, like on the other end, you have a bunch of those deployments, and they now know how to communicate themselves so that they can find the right basically target that you want to communicate. And then you build a kind of a custom DNS, almost like infrastructure on top, so you can find things.
That is correct. Yeah,
so I'm trying to simplify. I'm just trying to get my head around it, right?
Yeah, and you can put anything, right? And you can create your own DNS space. I'm using my own personal DNS, but basically you can just avoid DNS. Probably you just want to say, hey, I want that Squirrel can communicate with, I don't know, Postgres DB1, right? And you're not putting any DNS. It's just naming convention that you're using. Or probably you want to recreate your own, basically networking, right? You work for many other companies, and this is going to help you to flat that network as well.
But also to completely protect it, right? Because if, for example, at the moment with VPNs, you have to give access to a huge amount of stuff, right? With this, you almost create connections, right? Based on what we want a particular service or user to access.
That is correct. Basically, you just provide the access to those specific services, right? I don't want you to have access to the whole server. The only thing you may have access is to the SQL, right? To the Postgres, because you're the DBA, but you don't have to connect via SSH. It's just DBA. That's it. And I'm not going to give you access to your computer, just to the application you're using, right? That's it.
So have you had use cases where you actually use this, for example, inside a Kubernetes cluster to lock down access even within the cluster?
You can, of course. You can do micro-segmentation. You can actually allow some specific services running on the cluster. You can actually allow that some specific containers or some specific application running on the cluster may have communication externally as well. And of course, if you're talking about Kubernetes, you can also say, you know what? I want to manage my Kubernetes cluster without exposing any public IP, and only the administrator of Kubernetes can connect to it, right? And yeah, that is an opportunity. That is an option.
So in that case, what are you installing in the cluster? Are you installing a server or the client?
But that's a good one. So from the cluster perspective, you have the ability to use our Helm charts. And using the Helm charts, you can basically install some other application running the cluster that is going to work as the bridge, right? And that is going to provide basically that communication, being quite simplistic right now. On the other hand,
just to clarify, so by bridge, you mean I could call a server, right? Like the server unit. So okay, let's say if I have two complete separate clusters and then a server on somewhere else, what you're calling bridge is almost the service that runs on each of those to allow them to communicate.
That is correct. If I do have two different clusters, I can make them communicate to each other. If I do have an application running on this cluster that needs to have communication to this database living on any cloud provider, and I don't want to create any VPN in there, I can also put it in there, right? I can just put the application running in the cluster as well, and they may have communication to the database. No code modification, no agent installation, basically directly on top of the Kubernetes as well. So basically you have the ability to put it anywhere, right? Any to any.
Yeah, and then it's just to make sure that those bridges can talk to each other, right?
That is correct. Yeah, to each other. Yeah.
And I'm assuming that the bridge is then where we can enforce strong authentication, SAML authentication, or even all sorts of key-based authentication, so that that connection between bridge to bridge is actually quite secure.
That is correct. All communication is going to be completely secure, right? You can work with mutual TLS. We also work internally with the Chachapoli. And of course, you also have the ability to, for the end users, you may say, you know what? If Marcus wants to connect there, not only he's going to use his strong identity, but also he needs to use probably an MFA, right? Of his identity. It might be on any, basically, a smart card or any strong identity solution that I may want to use, right?
Cool. Yeah, that was my next set of questions is, in terms of client identity, right? What kind of what do you support in terms of identity identifying, the user, the network that you're in, the device that you're in, what's the options there. So this is from the client, right? That talks to the bridge.
That is correct. So from the client perspective, you have the ability to put basically MFA, any TOTP solution that you want to start working on it, it can basically use it. And because it used that specific, you can basically put the identity into any hardware piece, right? I don't know, HSMA, I think it is called, right, in English, the acronyms, but basically in a smart card, YubiKey, whatever, right? You can just put your identity there and you can just plug it into the computer. And if you have the client, you may be able to connect, right? So basically that's how it works.
Yeah, really, really cool. I see tons of really powerful adoption. I think it's really great that you guys build this on top of open source because it allows, a lot of more flexibility on the deployments and then providing commercial service on top of it. But I think it allows for wider adoptions in places where sometimes you cannot have connections to the outside world, right? Or you only want to have specific points that connect to the outside world.
That is correct. Yeah, that was basically the idea, to make it a completely open source, right? It's an open source project, and I invite you to use it, right? To start testing it, to fork the repository, to basically download it, or just use it for your own purposes, right? I'm like I said, right? I'm super paranoid, and I used to have these droplets located in the cloud, right? Different ones, and the way I used to access those was basically using VPNs, and to open the VPN to those, I was using like port knocking because super paranoid. Right now, it's like I just connect to my client and I can reach out any server, wherever I need to deploy it in an easy, secure way, right? So I invite you all to do.
So let me say a workflow. So I could deploy this on, for example, an AWS EC2 instance, right?
Yeah.
And now it becomes my bridge, using a terminology. And then that could be the only thing that gets exposed to the outside world.
That is correct. Yes.
So that means apart from public services, okay, something we expose here and there, a website we publish, everything else, it's almost like we can create a jump box with this, right?
Kind of like a jump box, but a secure jump box. That is correct.
Well, I was going to say a much nicer beefed up jump box, right? Because usually jump box is just a freaking SSH proxy, or a bit like you jump into it and you go in there. But so this seems to me like it's a jump box, and that you can then I guess in that case you then have policies that you can apply to it, right? So you can have it's almost like you have a jump box, but that could be connected to another one that gives them the policy. How do you manage that distribution?
That's correct. Yes, that is the perfect example. I couldn't say it better. Yes.
Very, very cool. No, yeah, I think there's definitely, I think it would be really cool to do a couple more sessions around it, because I think it's such a powerful concept, right? I really like, as as a good example of zero trust networks, right? It seems that this is hitting a lot of those key elements, right? Because you now have conditional access based on who you are, what you want to access. And what I really like is the ability to almost start to create, a nice segmented sort of zero trust access, right? So if an app can only connect to, X resources, that's the only thing you should be able to access, right?
Yes.
And is this, in terms of DevOps, kind of this thing, right? Like in terms of pipelines, what examples have you seen where, let's say that the definition of what needs to be accessed is actually on, a CI, a repo, right? Like I'm just thinking in terms of scalability, right? So for example, like you have the Helm charts that already define the ports that are open and all that jazz, right?
Yep.
How is the logic then that you would configure that, and then as you deploy the application will configure the what's required for the access. Is that the logic?
That is quite the logic. So basically, we do have, in terms of DevOps perspective, we do have everything ready. So you can start using in the CI/CD pipeline, right? A communication to the different artifacts that you can currently use. You also have the Helm charts that you can basically deploy and start making it ready to start communicating your solutions. We do have also Terraform issue or Terraform ways you can start doing it. And on the OpenZiti side, the docs, if you go to city.dev, and you also will going to find basically the Kubernetes cluster ready, so you can even deploy the solution on top of a Kubernetes cluster and just making it happen, right? And we have lots of examples where you can start basically using it. We have Citify also kubectl, right? If you need to manage your basically your Kubernetes cluster, you don't need to install any agent. You can basically just use our kubectl solution as your identity to that and start managing the cluster as well. So basically, it has all the tools already ready, so you can start working with it.
Cool, man. This is really good. Like I definitely, I really need to use that. I need to spend some more time on it because I think it's a great implementation. I can see lots of really powerful use cases. So let's do a couple more sessions on it. Let's really try to get a power on top of this, right? Because it's actually really powerful, and I can totally see, the value of and then the solutions you're solving, right? So really cool.
Yeah. I invite everybody to connect, right? To fork it, use it, and giving us a start as well, right? If you like the project, if you trust the project, just giving us a start. That is gonna encourage us to keep moving and keep working on it.
Now, where are you guys based? Where's everything based?
Company is based on basically North Carolina, although we are working, across the world, basically.
Yeah, cool. All right, man. Look, brilliant. Thanks a lot for doing this session, and I look forward to seeing you on the next ones.
Of course, it will be my pleasure. Thank you, everybody, for your time. I'll see you next time.